I will be speaking on the topic of development of low-torque progressive captive pumps using intercross-linking network structure gels. First, let's talk about the research background. Progressive captive pumps are positive displacement pumps, commonly called PCPs. It consists of a rotor and a stator, and transporting fluid while moving in an eccentric motion. PCPs can be used in a wide range of fields. This time, we focus on the major feature of PCPs, which is that they can be transported without damaging the fluid. This is due to the structural features that the fluid in the pump is not easily shared by the continuous transfer of a series of independent seal space called cavities between the rotor and stator, and the material features of the elastic materials used for the stator. Objective of this study. In this study, we focus on the stature of PCPs and develop a gel stator using a soft polymer gel. We researched whether the pumping ability could be developed by keeping the flexibility and low friction of the gel, and aimed to create a pump that could discharge at low torque. We will discuss the utility of gels in PCPs by comparing their performance with commercially available stators. We chose intercross-linking network structure gels because of their low friction and the possibility of using a 3D printer. Another reason for adapting this product is that it was developed in our laboratory. Next, I'd like to talk about stator mooring. For the gel mooring, we used Hunter, a DLP printer from Flash Forge. The stage is formed by UV light projected from the bottom of the tank. This data took about 5 hours, including support. In addition, since the gel stator is too soft to be attached when tested in its original state, an outer frame was created. We used Shuffle 4K LCD 3D printer from Frozen for mooring the outer frame. It took about 5 hours, including support. The main reason why we used Hunter for the gel mooring was that we had knowledge of the printing conditions for this shape. Here is a simple experiment using the gel stator we made. Colored silicone oil is inhaled by a hand crank. Here comes the performance test. First is the torque test. The rotor was one built into the PCP dispenser. We also measured the torque without the stator attached, that is, the torque at the other steering part. The torque value was calculated as an average of over 30 seconds. Silicone oil was used as the fluid. Here are the results of the torque test. The rubber stator had a larger torque value and standard deviation. Next, looking at the gel stator, both the torque value and standard deviation were small. It can be seen that the torque value is so low that there is almost no difference from the torque value without the stator. The ideal result of almost no torque was obtained with the gel data. Next is discharge volume test. As in the truck test, only the stator part was changed to compare the commercially available rubber stator and gel stator. Measure the discharge and divide by the density of silicon oil to obtain the volume. Next, the theoretical discharge rate per revolution is discussed. The formula is as shown here. The stator we created this time was modeling with the size shown in the table. The rotor diameter and stator inner diameter were designed to overlap by 0.1 mm to improve vision. In addition, we found that silicon oil leakage occurred even when the gel stator was stopped. Therefore, leakage was also taken into consideration in the result. Here is the result of the discharge volume test. The graph on the left shows the change in discharge volume according to the revolution rate when the rotation speed is fixed. The graph on the right shows the change in discharge volume according to the rotation speed when the revolution rate is fixed. The blue circle are the measured value of the rubber stator. The red square are the measured value of the gel stator, and the red crosses are the result considering the leakage of the gel stator. The left graph shows that there is a proportional relationship between the revolution rate and the discharge volume. Also, the right graph shows that the discharge volume of the rubber stator is constant regardless of the rotation speed. However, if we look at the discharge volume of the gel stator, we can see that the discharge volume at 5 rpm is greatly reduced. Finally, a summary. In this study, we were able to fabricate low-torque PCBs by 3D printing of IC gels. The created gel stator showed a low torque value that did not differ from the without stator, and the discharge volume increased with increase in revolution rate, which is a feature of PCBs. However, its discharge volume was found to be much lower than that of the rubber stator. In the future, we will improve the discharge volume and increase mooring accuracy, just the gel solution, and change mooring size. Finally, we hope to create a pump that can transfer breakable particles without leakage. Thank you.